Very good. Hello, climate changers. Today we're going to talk about signs of modern climate change, and it's probably going to be another long video. Sorry, but I do have my timer going, and yep, the volume is on, and when it goes off, it's time for you to take a break, or you can take a break whenever you want. But it's just a reminder for you to not get bored and to make sure you take breaks so that you can pay attention while you're watching the video. Okay. So, signs of modern climate change. What is this all about? Well, let's review what we've got so far. We know that the Earth is very old and that we have evidence of events that occurred in the Earth's past long before humans were ever here. And you should be able to list what some of those events are and how long ago they were. And we have evidence that the climate has changed before, sometimes quite dramatically. The Earth's atmosphere has changed many times, and the associated climate has as well. So we shouldn't be surprised if the climate is changing now. So let's ask the Earth, hey, what's up, man? What's up going on with you? We do that scientifically. And here is what's up with Earth's climate. It's been changing recently. And we're going to say what are these changes, and we are going to think about these changes independently of wondering why it's changing, because we'll get to that soon. But right now, let's just simply clear our minds and look at what the evidence says for climate change modern. So we have 6 symptoms of climate change already observed and probably accelerating. This is what's up with the Earth's climate. Number 1, there has been a warming of the air and sea, of the atmosphere and the oceans. Sea level rise has occurred. So the sea is getting taller, deeper, sea level rise. There is a decreasing amount of ice globally. We're talking glaciers, ice caps, and sea ice. Okay, so an ice cap would be like the ice over an island like Greenland, and sea ice would be like the ice on the North Pole because that's a sea, and then glaciers would be like in the mountains. Okay, apparently this is decreasing. On number 4, there are changes in precipitation, and we'll talk about those. Number 5, more severe weather. And lastly, number 6, there are ecosystem effects. So in this lecture, we are going to go over each of these and talk a little bit about them. Okay, number 1, warming of the atmosphere and oceans. Well, let's see, what do we got here? Let's look at our source first. Oh, nasa.gov. I trust NASA. If they can send ships to Mars and have them land and take pictures and drive around stuff, they're pretty awesome. So I think that's a reputable site. If you don't think they're reputable, come up with one that is and check their data. Let's look at the graph. On the x-axis, 1880 to about now, so a timeline on the bottom. On the y-axis, something called a temperature anomaly. What's that mean? Well, let's look at the title. Global Land Ocean Temperature Index. Okay, so what this means is that they can't give you one temperature for the Earth. Instead, they've taken lots of different measurements and averaged them and mixed them all together and come up with an index that connects both the land and the oceans. That's pretty complicated. Let's trust that they can do that. I don't know how they would do that, but it's pretty awesome that they can. Let's look at the lines here. Red is a 5-year running mean. So the red line went down until like 1910. Then it's been going up since then. In black is the annual mean. Okay, so that's every year going up and down. That shows you some variation from year to year, plus a 5-year average. Okay, so that's useful. The green lines here are there to indicate standard deviation. It's a statistical thing. You don't have to worry about it. Okay, so it looks like, oh my God, the temperature's going up. We're all going to fry. But wait a minute. 0.2, 0.4, 0.6 degrees centigrade. 0.6 degrees centigrade. Is that a lot? No, that's not much at all. That's a little bit. It's a degree or 2 Fahrenheit. That doesn't seem like much, but about 1 degree centigrade change in 100 years. 1 degree centigrade. Is that a lot or isn't it? Well, that's the question, isn't it? Okay, just think about this. What does the temperature of oceans influence? If the ocean warms up a little bit, what does that mean to the climate? Well, warm water means that more water will evaporate. So, on a global scale, we'll have more water in the atmosphere. More water in the atmosphere means more rain, more clouds. Okay, well, so what? Let's hold that question and come back to it in a sec. But in any case, okay, 100 years of warming. Okay, here's the deal is the warming of the earth is not smooth or equal. So here's a picture of the globe, both sides of the globe, and here's the average temperature difference. So this is change in temperature from the average. So you notice the red areas have warmed more and the blue areas have actually been cooler. So in some places, in some years, and some times, it's warmer and colder. So where that warming and cooling happens is very important to the people who live there. Okay, here is an animation I'm going to show you, a 100-year animation of changing global temperatures. So apparently they have data from the entire globe. They don't actually. There's some places they don't have good data for in the past, but it's gotten much better recently with satellites and electronic communication and digital stuff. But their best guess at reconstructing 100 years of changing global temperatures is in this video. Let's see if I actually got it here for you. Here we go. It's a different color. Okay, let's make it big for you. There we go. Let's play it. Okay, we're starting in 1886 to 1890. So, oh wow, it was really cold up here. Some warmer spots. And the orange, of course, is warm and the dark blue is cold. So let's let it play. Getting a little bit warmer. A little bit warmer maybe in some spots. No. Oh yeah, let's stop it here. Where are we? 1930. Okay, this is the Great Depression. Right around here, we start to see some warming, especially up north. That's important. Keep going. 1950s. The whole globe, even the tropics now have lost that blue color. There's still some dark blue, but not much. Pretty much everything has started changing color. 60s, 1970s, 1980s, 1990s, and we're going to stop right there. Okay, so yeah, okay, global, we've got a lot of, well, some warming, and bring it right to the very end, and we see, okay, yes, on one hand, we have global warming. On the other hand, it's not equal everywhere. Look down here in part of the Antarctica, it's not so cold, not so warm, but up north, wow, seems to be a lot of warming up towards the North Pole. Why is that? Let's get back to our slideshow and I'll answer that for you. Oh, I have to do this stupid thing. Okay. Another picture just capturing the picture in 2005, surface temperature anomaly, again shows the same thing. A lot of warming in the North Pole, some warming in the South Pole, not as dramatic. And here is the observation. Warming has been greatest at high latitudes. What's that, high latitudes? Well, 0 latitude is the equator. The North and South Pole are 90 degrees. And so that 90 is higher. So more warming towards the poles. That's interesting. Why? Here's what they say. There's been an amplification of warming in the Arctic up here due to a decrease of albedo. Albedo is a very important concept. We will be talking about it throughout this class. It has to do with reflectance. So where there's light colored earth like snow and light colored rock, I guess, ice, the sun's energy reflects back out to space, leaving no warming behind. But where that decreases, the light that would have bounced off now is absorbed by the sun and it adds to the warming. So that's why there has been an amplification of warming in the Arctic. We'll be talking about Arctic sea ice again soon. Okay, I just wanted to look at this one picture. This is a picture of a single time period. I guess it's the average for January 2014 recently. And point out that it was a cold January in eastern United States. There was what's called a polar vortex. A big blob of cold air came down and sat over the east coast for a while before clearing off. On the west coast, we were a little bit warmer. Ooh, up in Alaska, they're having a balmy January. Almost ruined the Iditarod, I think. So, I mean, that happens. But unfortunately, someone forgot to tell one of our senators about this. He is Senator in Hof. I'm not sure how to say his name, in Hofe, really doesn't believe that climate change is real. And so he wanted to take his point of view to the Senate. And this is what he said. Okay. I hope this audio comes through for you. Okay, actually, the Mr. President of the Senate did not catch that snowball. It was a page boy who caught it. And so, what's his point? He's trying. Well, yeah, you can. Yeah, that would be a good one to watch too. Let's get back to our PowerPoint, though. What was he trying to say? I think he's trying to say that because it's cold outside, there's no climate change. He's confusing weather and climate. Does he not have science advisors? Can't he look at this and discount the fact that there's a temporary polar vortex making it cold outside? No, he's a politician. He's not bound by the rules of science. He doesn't have to think critically like we do, which is not good. Okay, so I just wanted to show you that one way policymakers get involved in the debate. And we'll talk more about policy and the debate in this class later. Okay, so warming of air and sea, no doubt that it's happening. Maybe not on a day-to-day basis, but overall, yes. And I forgot to start my timer, so pretend that 15 minutes went by. I'm going to take a little sip of tea, and we're back. Okay, we're really counting down now. Okay, number 2, sea level rise. What's up with sea level rise? Okay, another graph. Let's see. Okay, I'm not quite, I forget where I got this graph from. Someplace reputable, I hope. Sea level rise is occurring at a rate of 1 to 3 millimeters a year. A millimeter is about the width of your fingernail. So that's not very much. Let's look at the, or is it? Let's look at this graph. It's another 100-year plus graph. And trend based on tidal gauges. So what they had was data from tide measurement devices all over the world, and that data has been amassed in one place and averaged out. Okay, and so that's this orange line, and I think that we have a plus and minus, some variation in that, which is not to be surprised. Look how old this information was. Older information, less accurate, and so we get a higher degree of variation. Newer information, since the 1950s, everyone's gotten more careful and more accurate, more standardized probably in how they collect the data. Then the University of Colorado started, and the Australia's CSIRO have been collecting data from satellites. We have 3 different sources of information since about 1990 whatever, and which is nice. If you have independent sources of information, then if they say the same thing, we have more confidence in it. If they say different things, then we have to resolve the differences. And what we have is a high degree of confidence in this upward trend on change in sea level rise. This is in inches, by the way. So let's see, it was 0, 1870. From then, it's gone up about less than a foot, 8 or so inches, this much. So what? Well, here's the thing. The IPCC, which we'll be hearing about more, the Intergovernmental Panel on Climate Change, stated in their fourth report that sea level rise seems to be accelerating. So, although overall, since 1901 to 2010, it's only 1.7 millimeters per year, and since 1993 to 2010, it's 3.2 millimeters a year, which is why we have this very 1 to 3 millimeters a year. One back then, maybe 3 millimeters per year now. So what? Okay, let's just take 3.3 millimeters per year. And I Googled, well, I multiplied it in my head by 100. That's 333, we'll say, 330 millimeters per year. No, 330 millimeters in 100 years. What's that? Because I don't know how many millimeters, how much that is. So I Googled it. 330 millimeters is what in feet? I Googled that, and you get the answer. It's about a foot. So, okay, in 100 years, that means in 100 years from now, if sea level rise doesn't accelerate, we'll go up another foot. So, is that a lot or isn't that? Well, here's the deal. Look, right now, this is a picture not uncommon in the Arcata bottoms. It's agricultural land. It often gets flooded out by rainwater when we have heavy storm events, but also there are certain tides that come up pretty high. And if these two things happen, sometimes we can get, there's this thing called a levee. It's an artificial hill between you and water on the other side. It holds back the water. So all around Humboldt Bay and any bay on the planet where there's a lot of people using land, they've put up these levees to hold the water back. Well, our levee isn't equally strong everywhere. It was built by a bunch of different people, some governmental, some commercial, some private, not all to the same standards. And in this case, the levee has failed. Here's an aerial view from 2004 of the Arcata bottoms, and you can see that this levee right here had failed, and so salt water would then rush onto the farmer's field. Salt water is not good for meadows. It kills the grass, replaces it with saltgrass, I don't know, other stuff that cows don't like. And so that represents a commercial loss. It may also, if this dike is breached and it starts going over roads or rails or other residential areas, we've got a social problem, a big social problem. So a 1 inch, if this is happening now, add another foot to this and couple it with high tides, maybe a storm or something, and yes, that 1 foot does become important. It will actually can be calculated, the potential economic losses due to these things, and you should not be surprised about this. Here's just before I show you more pictures. Stick with me. During the last interglacial period, about 100,000 years ago, the sea level was at least 5 meters higher than present. That's 16 feet. Are we going to go there? 16 feet? Well, the predictions only say 100 feet in 1 year. No, 1 foot in 100 years. So I don't know. But we don't really know the future. We don't know how fast a lot of the ice is going to melt. We would hope not. But think of this. Samoa Boulevard outside Arcata, if you know where that is, which you should, is 12 feet high. So yeah, if water went up 16 feet, all of Samoa Boulevard would be covered, plus Highway 101 throughout Humboldt Bay, plus a lot of other places. By the way, the Arcata Plaza would be safe at 35 feet, but the water would be lapping right at the bottom of the hill there, the little hill. But that's just Arcata. I had a student once ask me after going over this stuff. She said, well, why should people in South Dakota care about sea level rise? They don't have to worry about it. They're not there. And I was kind of stumped by that, because I just thought that, well, they would care just because. But it's a good question, because how people often care because it affects their livelihood. If it doesn't affect their livelihood, so what? Well, that's a jaded way of looking at it, but I think it's legitimate, and we'll address that. Look, I got this picture from montgomery.devon.school.uk. So some United Kingdom school made this nice map. Thank you. And it shows not the names of the cities, but the location of the major cities of the world. So we got your San Francisco, Oakland, Bay Area, Mexico City, New York, Boston, Washington, Rio. I don't know these. I'm sorry, a little bit ignorant. London, Paris, Cairo, Istanbul. Hong Kong is over here somewhere, and let's see, Tokyo, Seoul, South Korea, and all these major cities, millions and millions of people, and all the economic activity built on shorelines because that was a place where a lot of commerce takes place. If they are suddenly flooded, as New York City was when Hurricane Sandy hit, or as New Orleans was when Hurricane Katrina hit, the effects go far beyond the people who live in that city. These cities are centers of commerce. If, let's just say, okay, let's take New York City. New York City shuts down for 2 days. Guess what happens in New York City? A lot of economic activity. If Wall Street is not running, then the world markets are kind of shut down for a day. Does that affect the people in South Dakota? If they're investors, which most people are, and even if they're not, if some kind of disruption like this may hurt the world economy, that could translate to jobs. Okay, so if there's a slowdown in automobile production and South Dakota or wherever inland has an automotive transportation plant, they can't get their parts, there's no demand, they can't go to work, they're out of work, sea level rise has affected them. Okay, connect the dots. Okay, but I just want to be clear about something because students are wonderfully good at misunderstanding me. And I'm sure that this is a possibility here because I'm conflating two different things, sea level rise and hurricanes. So I showed you pictures from that are the consequences of two tropical cyclones or hurricanes. But sea level rise caused by global climate change will exacerbate coastal flooding events. It's not clear yet whether climate change will increase the number and or severity of hurricanes. We'll talk about that in a moment. But so while I was talking about these guys here, what I was saying was that if this level is higher, then when the flood inevitably comes, its consequences will be worse. That should be clear. Okay. Okay, hey, what causes sea level to rise anyway? It's not obvious. You might think, yeah, melting of ice caps and glaciers. That's what most people would think. But also thermal expansion of the ocean water. So that 1 degree centigrade change in the climate, the small change in temperature of the ocean actually causes the ocean to get bigger to a certain extent. Add to that more water from melting ice, which was above sea level, being added to it. Those two things together cause the sea level to rise. I think it's kind of cool. Thermal expansion. Uh-oh, just a scary thing. If Greenland melts, so Greenland, a big kind of island off the right side of Canada, has an awful lot of ice on it. And someone once calculated how much ice was on it, and then you could calculate if it melts, the sea level rise would be 23 feet. Yikes! Much greater than what happened 100,000 years ago. So we hope that doesn't happen. And guess what? That's just Greenland. What about the Antarctic ice cap? Ooh, we'll talk more about that later. I don't even want to. It's a scary idea, but we have to address it. Okay, so we've talked about warming of air and sea. We've talked about sea level rise. These things have been measured and are happening. So number 3 that is also being measured and happening is decreased ice of glaciers, ice caps, and sea ice. So here's some pictures of melting glaciers. So here's one from Alaska, here's one from Colorado, and it looks like these two pictures, one is 1980, 2005. Note the little island mountain there. Here it is. So this glacier, which had a tongue of ice going out into the bay, has retreated almost to way past this point. Okay, so that glacier is retreating. Here's one in the mountains in Colorado. Notice this little notch here in that white line of rock. Here's the notch in that white line of rock. glacier used to come way down here. It has retreated. We now have a tarn or glacial lake there, and you can see that it has retreated. So this has happened not just in Alaska and Colorado, but all over the world. And it takes an army of scientists to study only glaciers to go out there and document these things and report them. And it takes someone else to gather up all that information and show a global trend. It's called a meta study. And if you do that, what you get is since 1500 to 2000, if you plot out the length of glaciers all over the world, you see they're all getting smaller and smaller and smaller. So glaciers are going away. They are retreating all over the world. Why should you care about glaciers? Great question. I don't have one in my backyard. I'll be fine without glaciers. Well, other people won't be. Check this out. This is Google Earth. Okay, and we're going to go a place where there's a lot of glaciers. One of the places where there's a lot of glaciers is, let me tilt the screen here a little bit. Let's zoom in. This is the Indian subcontinent, and as you know, the Himalayas are right there. And so let's zoom in on the Himalayas because they're beautiful and awesome. Okay, here we are. I don't know where Mount Everest is, but it's up here. And you see that they are capped with enormous, beautiful glaciers. Let's see if there's any pictures here. Do 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 do. Sometimes it's got to reload. Oh, there are pictures here. What is this mountain? The five-peaked Panchuli group. Let's see what this is. I don't know if you can see this, but I can. Beautiful mountain, glaciers. Yeah, so great. So these mountains, the Himalayas, have an enormous number of, let me turn the photos off, an enormous number of glaciers. A lot of water gets stored up there during the monsoon seasons. And then in between, it melts. And when it melts, of course, it flows down into these rivers. So these rivers have a steady supply of meltwater from the mountains. And where does it go? It goes down, 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 just following any old river coming out of the Himalayas out into India. And here's a big river coming out, joined by lots of other rivers. And what's going on next to these rivers? Anywhere you look, farms. Look at all those farms. And these little gray dots are all cities or towns and cities. Look at all the gray dots. There's about 1 billion people living in India these days. And they all depend upon the food produced here. And they depend upon that meltwater. And if it disappears, they're not going to get as much water. We got 1 billion people depending upon that. If they don't get as much water, what a problem. Look at the scale of this problem, this potential problem. All this stuff draining into all this fertile problem in India and Bangladesh. So those are people over there. Okay, what about people over here? Let's go home. Oh, the alarm is going off. Reset. Okay, take a break. Okay, we are back. I have reset the 15-minute alarm and we're zooming in. We've just been in the Himalayas and worrying about them if their glaciers dry up. What about us? Let's look at California. I'm going to tilt this screen too. So here we're zooming into California. And you guys know this. Here's the Bay Area. Here's Los Angeles down here. And in between, in the Central Valley, we have some of the most fertile farmland in the world. And agriculture is a huge part of our state's economy. And we are supplying a lot of food for the world. These plants all need water. Where does it come from? Some of it is pumped from groundwater. The rest would come from these rivers, but the rivers are kept supplied mostly by snow that falls in the Sierras and then melts. Now, if that snow's not there, then these reservoirs don't get filled up. Almost every creek that comes out of the Sierras is dammed up, and that reservoir gives us electricity, and it also gives water, mostly for irrigation and drinking water. Okay, so we, just like the folks in India, depend upon this for our livelihoods and our economy. And so if that changes, we have a large economic and social disruption. Okay, that's why you care about the retreat of glaciers. One reason. Okay, hope that's clear. Moving on. Okay. Some of the glaciers, like the big ones, seem to be becoming less stable. We're talking specifically now about the Greenland ice sheet. We'll be talking more about this later in the class, where we focus in specifically on this problem. But there's some idea that the Greenland ice sheet is getting thinner. Here's a 10-year difference in the amount of the aerial extent of the glaciers and ice caps over Greenland. So, if you believe these maps, they are surging and they are melting. And Al Gore talked about that briefly in his famous Inconvenient Truth movie. Okay, just briefly, there's too much text here, but I just wanted to point out that we'll come back to this later in the course, but the Arctic sea ice is also seems to be shrinking. Now, it grows every winter and then it melts back every summer, and so it fluctuates back and forth. A little bit hard to measure, but we can and do measure that extent. Recently, in February of 2015, the Arctic sea ice has reached its maximum extent, but this year's maximum ice extent is the lowest that's ever been in the satellite record. Okay, so not as much ice froze this winter as ever before. And we will see this summer how far it retreats. Currently, there are projections that the Arctic ice cap, actually the Arctic Sea, will be ice free in summer, which has never happened before in recorded history. And people are now starting to exploit that. Oh, great, we now have a Northwest Passage and we can take boats through here. Also, we can go in there and sink drills and get more oil and stuff out. Okay, I'm not going to say anything about the text. So this is happening. Okay. So we have decreased ice of glaciers, ice caps, and sea ice being the Arctic Ocean, Arctic Sea. Changes in precipitation. What's up with that? Okay, changes in precipitation. There's more rain in some places and less in others, which makes it really difficult to measure. But here's what the experts have done. This is from the IPCC 2013 report, Intergovernmental Panel on Climate Change. Okay, and we'll define them later. For the time being, just trust them. We'll look at them critically later on. I trust them. Okay, so here's 100 years of observed change in annual precipitation over land. Brown is less rain, blue-green is more rain. Some places are getting more rain. Northern Europe have been getting more rain. Some places are getting drier, the Sahel, parts of Indonesia. Okay, but let's take a closer look. That's a 110-year span. If you just look at the last, say, 60 years, the situation is slightly different, more exacerbated. The Pacific, we'll come back to North America in a second. Check this out. The Sahel, much drier, really bad for those folks who live south of the Sahara, very stressed out. China, part of China and Korea and Japan, and all throughout the Mediterranean. The changes in precipitation, the drought in the Mid-East has been linked directly to social unrest in that area. I saw a wonderful paper that linked the Syrian civil war, which the United States has gotten sucked into with the subsequent emergence of ISIS as a global terrorist threat. That was caused in part by drought conditions. The folks in the country had to leave their homes. They came to the city. They weren't taken care of by the government. They became upset. The civil war began. That's started and spread throughout the Middle East. Well, we'll see what it's doing right now. So that's, I'm sure, a great oversimplification, but at least a contributing factor. So you could tie climate change to social unrest, and then to global events. You probably wonder what's going on locally. Look, it's kind of surprising, because currently we're in a big drought, but it's surprising to see that over the last 60 years, we have been getting more precipitation than formerly, which is pretty exciting, pretty interesting. And this information is backed up by biology. Bristlecone pine tree rings. Bristlecone pines live in the White Mountains of California, just to the east of the Sierras. They show that the last 100 years in California have been wetter than any century in the last 1,000 years. So maybe there's hope that we're not in a mega drought. Maybe we'll get rain, but sometimes you have to be careful what you wish for. If we get torrential downpours, that could be bad for some people as well. Also, if the precipitation comes as rain and not snow, then it runs off and we still may have a drought problem in summertime. Okay, and everywhere on Earth, people are dealing with changing precipitation patterns, and that causes problems of adjustment. Okay, changes in precipitation done. Number 5, more severe weather. Now, your book talks about more severe weather. When I look into it, it's actually a little bit problematic. It's not exactly clear whether this is happening or not. It is definitely a prediction of global warming and climate change that more severe weather will happen. But whether it's been observed or not, when I look around in the literature, it's kind of mixed. The scientists are hesitant to say yes, and there's a reason for this. The problem here relates in part directly to the difficulty of relating weather and climate. So a severe weather event is a weather event. It's not climate. It's what you get, not what you expect. And so when we get these, what happens every time there's a severe weather event, the climate change camp says, you see. But then if it doesn't happen, the other side's like, if it's cold in Washington D.C., the senators start saying, see. And so they're not being critical about it. They're not using science and the data and logic and all those critical thinking skills to address this problem. So that becomes a problem. But let's just go back and ask, what kind of severe weather are we talking about here? We'll talk about the IPCC predictions soon, but one of their predictions is definitely that we will have more severe weather. What kind of severe weather? Hurricanes, more frequent and stronger. So we call them hurricanes in North America. They call them, their tropical cyclones is a better name for them. They call them monsoons, or what do they call them? Typhoons in Asia. Okay, but they're all hurricanes. So the prediction is more frequent and stronger. Number 2, tornadoes. A tornado is definitely a severe weather event, and when one touches down on your property, you want to blame somebody, but you can't scientifically blame it on climate change, at least not yet. Floods, but just think about that. Whether or not there's a flood, it depends not only in whether it rained or not, but also how humans have been managing the land. There's some things humans can do that can make a weather event worse, such as clear cutting, such as poor farming practices, such as channelizing rivers, such as lots of other things. Okay, the other thing, that when there is a severe flood, it causes economic damage. But you can't compare today's economic damage to the economic damage of a similar event 100 years ago, because people have changed. There's more of us now. And it's hard to put a dollar value on things and then compare now to yesterday. People try, and the very expensive billion-dollar severe weather events seem to be increasing. So whether climate change is a part of that or not is difficult for a scientist to conclude. Feels like it is, but it's hard to be fairly critical about it and conclude that. Droughts, another one, and heat waves. Boy, you would think that global warming would cause more heat waves, and that's a prediction, but to tie individual events to climate change, hard to do. But stay tuned. Oh, and even cold waves, like those polar vortex that the senator was complaining or marshaling in his defense, could also be a consequence of climate change. That's interesting. Okay, so we're gonna sort of punt on whether severe weather is occurring because of climate change or not, but I wanted to put it out there because it's a very important aspect predicted of climate change. Lastly, ecosystem effects. And this is the most difficult thing of all to get a handle on because an ecosystem is an enormously complicated thing with many different players in it. And so it's hard to tease it out and then relate the climate to any change you see in what is already a dynamic system. But here's what some people think they have seen, that scientists are reporting they are seeing because of climate change: changes in the distribution of species and of ecosystems and in habitats. These are moving around when they can in response to climate change. That there's been a disruption of breeding seasons, especially of animals and plants. So if your breeding is timed to certain times of the year where you would expect a certain weather, that may not happen. It may be warmer earlier, and then by the time you bloom, your pollinator has left, and so you don't get pollinated, and so your life cycle has been disrupted. Coral reefs are declining for a number of reasons, and one seems to be because changes in ocean temperature. There's an accelerated extinction rate. Already there's a huge extinction rate because of human activities. This is apparently being accelerated by the ecosystem effects of climate change. And I just wanted to give you one example just to show you how real this can be. This is a mountain pine bark beetle balanced on the end of a match. Okay, so what? Well, here's the dude. First of all, it's a native species, so it's native to North America. These guys live on trees and kill them. Warmer winters mean less mortality of mountain pine bark beetles and a longer breeding season. So it used to be we had colder winters and these guys got killed back and kept to the south. Now we have warmer weathers, and so there's more of them, and they're farther north. This increased populations of them means increased mortality of trees. So trees are dying in western forests that didn't used to. They're dying in such numbers that this is actually considered a blight and possibly the largest forest insect blight in North American history. So this is huge. You probably haven't seen it though unless you've gone traveling. I'll show you pictures in a sec. There is an increased mortality of trees plus a legacy of fire suppression. Smokey the Bear put out all fires, don't let any fires burn. Those two things mean more stand replacing intense fires. So you have a bunch of dead trees all jam packed together, dry as a bone. What's the next thing that happens? A spark is lit, they catch on fire, this burns. So then, with all those forests replaced, you have fewer trees and less carbon sequestration. Carbon sequestration is something we'll talk about later. It means less carbon being taken out of the atmosphere by plants. So we put carbon into the atmosphere as carbon dioxide. That increases climate change. If the plants would only take it out again, it might be okay. But that's harder for that to happen when the forests have all just burned. Not all the forests. It's an exaggeration, but that's the point I wanted to make. Fewer trees. I'm going to take a break. I'm almost done, but I might want to take a break anyway. Stretch. Clear your head. Okay, here we go. All right, fewer trees, less carbon sequestration. And there are many other consequences of this one example. Let me just show you some pictures. Okay, here's what the beetles did at trees. They burrow in, they burrow underneath the bark. Eventually, they completely sever the tissue underneath the bark, and that kills the tree. It's called ringing the tree. They get ringed, the tree dies. Lots of them die. This is not far from Mount Rushmore, famous national monument, and all these red trees are dead trees, trees that have died recently from pine bark beetle infestation. And you can see the whole landscape, the entire landscape, is experiencing a stand replacement event, and that's in thanks, North Dakota. It's in the Dakotas, and but the pine bark beetles are far beyond there. Look at this map. All right, here's let's see. Aha, must be North Dakota. There's that outbreak. And then all these red areas are pine forests that have been impacted right up through the Cascades. Hey, not so much in California, a little bit in the Sierras, not much, but look at this into British Columbia. Look at the size of that outbreak. That's about the same size of half of California. If half of California were losing all its trees, this would be on our radar, but it's our neighbors to the north, Canada, so we don't talk about it so much. Pretty intense outbreak. It's huge. It's enormous. And then you get these stands of dead trees, and then you get a fire, and in the end, you get something that looks like that. And so you have to expand your understanding of this beyond that of the beetle and the tree. What about the 50, 100, 400 species of birds that live in this forest? What about the bears, the wildcats, the lynx, the martens, the pine martens, the raccoons, the fish? What about the nutrients that are in this soil? What about all the soil itself? What about the gophers? What about the 10,000 other species of insects that used to inhabit these areas? That is an ecosystem level effect caused in part, in large part, by climate change. And that's just one example. This kind of stuff, maybe not so dramatic and widespread, but similar stories are breaking out all over the world. It's got some people concerned. Okay, so here's what's up with the Earth's climate: warming of the air and sea level rise, decreased ice, changes in precipitation, more severe weather. We're going to put a question mark behind that, and ecosystem level effect. So that is happening. The next question is, why has it been changing? Is it natural, or have humans been causing it? So in the next lecture, we'll be talking about natural sources of climate change, and after that, we'll talk about anthropogenic climate change. Okay, my kids say that I should end these long lectures with a joke, just to keep you guys engaged, and so I have a joke for you. Uh, that's right, I was going to tell you a chemistry joke, but all the good ones are gone. Get it? Okay, see you next time. Bye.